Hi, I am Varun Joshi and welcome to day 13 of our Certified Kubernetes Administrator 2025 course. Today we are diving into imperative commands in Kubernetes, which are super handy for quick testing, troubleshooting, and even during the CKA exam. We'll explore why imperative commands are important, how to create front-end and back-end deployments and services using them, and also see how to quickly generate YAML files with the -- dry run flag. We'll wrap up by creating a test pod to validate connectivity between our pods. Now, let's start this lecture by understanding why imperative commands are crucial. We already discussed what are imperative and declarative commands in day 9. If you have any confusion between what exactly is imperative and declarative, then I would suggest you to go and watch day 9. I'll link that in this video. Imperative commands are crucial for first is daily troubleshooting. Quickly create test pods or services to check connectivity or network policies. In the last lecture, we created front end, back end, and then we exposed them using services. How did we test that? We tested that using pods. And how do we create those test pods? You can create those test pods very quickly by using imperative commands. We have not discussed this yet, but there are something called network policies in Kubernetes. Network policies are there to ensure that certain components in your Kubernetes cannot speak to each other. For example, I don't want my web servers to communicate with my database servers. How do I ensure that? I can use network policies for that. And once you have implemented these network policies, then how do you test them? You can test them by creating test pods. So hence, imperative commands are crucial when we talk about daily troubleshooting. Second is CKA exam. Up until now, we have been creating declarative YAMLs from scratch, and no matter how fast we are at learning them or how fast we can type, imperative commands can do those things quickly. So we can use imperative commands to create a skeleton deployment YAML, for example, and do the required editing and then deploy that YAML. In CKA exam, which is time bound, using imperative commands can be a time saver for you. Third is real world scenarios, useful when testing accessibility, deploying temporary resources, or verifying configurations. Now, what we will do is in day 12, we deployed this architecture using declarative configuration. This architecture has 4 main Kubernetes objects. First one is backend deployment. Second is a backend service, which was of type cluster IP. Then third is front-end deployment. And the fourth is a front-end service, which was of type node port. We'll deploy all these 4 Kubernetes objects using imperative configuration in this lesson. So I'll quickly go to my command line. First, we'll be creating a deployment for backend. So let's do that. I'll write kubectl create deployment, and then I'll write -h here. This is the help for kubectl create deployment, and this will show me what all options are available. These are the examples that I am shown, and it will also show me all the options that I can use while using this command. You see that I can supply replicas, I can supply ports, image, and all these things. So let's create a deployment which will be similar to what we created declaratively in the last lecture. I'll quickly clear my screen. I'll write kubectl create deployment. I'll name this deployment backend deploy, like in our last lecture. I'll add a backslash so that this will give you proper visibility and we can write each command properly. Now I'll supply an image flag. In under image, I'll write HashiCorp HTTP echo. I'll add a backslash, press enter, then I'll write replicas. My replica count will be 3 like before. I'll again hit enter. I'll add a flag called port 5678. Now understand that we are creating a deployment in deployment, when you specify a port, you are specifying the container port. This is just for documentation purposes, because this actually won't expose your container on port 5678. If your application is listening on port 5678, this acts as a documentation that yes, indeed, the application that is deployed on this container listens on port 5678. I'll again add a backslash here, and I'll write dry run is equal to client. Dry run implies that do not just create resources and then the value that is supplied here. Here I am writing dry run is equal to client. This says that do not send this request to the API server yet. Just see whether whatever I am writing, the basic schema of Kubernetes is correct and the syntax is correct. You remember when we were discussing about kubectl and API server, we said that kubectl has two responsibilities mainly. First is to check whether the syntax of the YAML is correct. Second is it verifies the basic Kubernetes schema. If I would have written server here, this command would have sent this to the API server and verified whether this deployment or whether this command is formatted and written correctly. So I'll write client here. Client implies that do not create any resources, just check whether the syntax and the basic schema is correct or not. Then I'll write -o YAML. This says give me the output in YAML format, and then I'll write right angle bracket or greater than sign. This says that whatever the output is, redirect this into a file called backend deploy.yaml. I could have not written this and pressed enter and this would have created a deployment. But why I am writing this is, first, so that you know that you can use these flags. Second is, you will see in a little while. I'll press enter now. I have pressed enter. I am in day 13. So ideally this command should have created a file called backend-deploy.yaml in day 13. I'll go to Visual Studio Code and expand day 13 and you see that backend-deploy.yaml file is created. If I see this file, this looks okay to me, but what I'll also do is I'll quickly go to day 12 and I'll also open the backend.yaml here. I'll right click here and I'll do split right. Once this is splitted into right, I'll open backend.deploy here. I'll move this to here and I'll close this so that you can compare this side by side. There are few flags that are additionally added. What I'll quickly do is I'll remove these flags because we don't need these flags. I'll also remove this flag and this flag. What you also see is this command has also added a label called backend-deploy to the deployment itself. So there are labels to the pods and this is something that is adding labels to the deployment itself, and we didn't use it before. What I'll also do is I'll remove these labels too. The name of this deployment is backend deploy like we expect, and then match labels. What this command will do is, let's go to this command again. Whatever name that you define of the backend deployment, that is here it is backend-deploy, it will add the same name labels to your selectors and pod labels. So what we'll do is we'll quickly remove deploy from here and the hyphen. We'll also remove -deploy from here so that we have consistency. Let me quickly verify a few more things. First is writing it like this is also fine, but I always maintain 2 spaces indentation. So I'll quickly move this to the right. Now I have 2 spaces here. Another thing is, this is the additional 2 lines that we have. These are here because we mentioned something called ports there. As you see, this was not mentioned here because this is not something that is mandatory, but you should always write this so that anyone who is deploying your Kubernetes manifest knows that the pod that this deployment will create, The application will be listening on port 5678. This is just for documentation, but it is a good practice to write it in your deployment YAMLs. And similarly, I'll have 2 spaces here as well, like we did here. Now, what I'll also do is, you see that the arguments are not added. I'll add arguments also. ARGS arguments would be 2 spaces, and then I'll just copy this from here and I'll paste this here. Now let's see if everything is in line with what we had before. And indeed it is. See, we did not write this deployment, we just wrote this, and we wrote this, which is why a file was created for us. Now what I'll do is, I'll run kubectl apply -f, and the name was backend-deploy.yaml. I'll press enter. It says that the backend deployment is created. Backend deployment is now created. What we would want to do is, we would want to expose this deployment. Now to expose this deployment, we'll have to create a cluster IP service. Why a cluster IP service? Because cluster IP will enable communication between front end and backend. So we'll be creating this service now. This we have created. Let's go to the command line again. I'll write kubectl expose deployment backend deploy. I'll write -h here, which will give you examples. Here are all the examples for your reference, and then also all the options, all the flags that you can use with this command. What I will do is, I'll clear my screen and we'll write it from the very scratch. You can also refer the options section whenever you are in confusion. So I'll write a / here, then I'll specify the type of this service. The type of this service will be cluster IP. This is cluster IP because we are writing the YAML we are writing the imperative command to deploy a cluster IP service, which is why we are specifying cluster IP here. Once we are deploying this for the front end, that is front end service, then we'll be using the node port type. So here the type is cluster IP. Mind this is case sensitive. C and IP are uppercase here. Then I'll write the port on which this cluster IP service will listen on is 9090. Again, I'll hit /, press enter. The target is the container port, which is 5678. This is the port on which my application listens on. My application is deployed on a container and my application listens on port 5678. I'll again I have pressed enter by mistake. Let me kubectl delete svc backend deploy, and then I have to add few more options here, which is why I've deleted that and I'm adding those sections, those options. I'll add dry run is equal to client -o YAML backend deploy.yaml. I have added double right angle brackets because I do not want to overwrite this file. I just want this command to append my YAML configuration in the existing deployment YAML configuration. One more thing to highlight is, if I would have pressed enter here, I would not have written this, then also this would have worked fine. Reason being, whenever I am exposing a service, this command will create a service with the same label as the pods which are defined in backend-deploy. If you remember, backend-deploy, all our pods has the label app is equal to backend. So this would have worked, but to maintain completeness, I want the process to be similar to what we did for deployment. When we write the imperative command for node IP, then things would be different. That I'll tell you at that point of time, but right now whatever we have written works fine. Now I'll add one more thing here, that is the name for this service. The name for this service will be backend-svc. I'll now press enter, and if I go to my Visual Studio Code, you see that a new part is added to my backend-deploy. We learned from our previous lecture that you can separate different YAMLs using a YAML separator, which are triple hyphens. I'll press enter. and then I'll remove the unnecessary parts from here. I don't need these things, I'll remove them. And if you look at it, this is similar to what we did in our previous lecture. You see, we created this step by step, but with this command, we just wrote this command and this file was automatically created for us. Now what we can quickly do is we can write kubectl apply -f backend. Before pressing enter, I'll quickly verify this file. Okay, backend svc is the name, selector is app is equal to backend, which is why it will select all these pods which are part of this deployment, and then I'll press enter here. You see that it says the deployment is unchanged because we didn't do any changes in here. However, it says that the backend service is created because this was something that was newly added here. If I run kubectl get all, I see that I have a backend deployment, which is this. It is supposed to have 3 pods and it has 3 pods, and all those 3 pods are running. We also created a backend service, which is this service, and if I run a kubectl describe on this service, I will see that there are 3 pods to which this service is load balancing. If I run kubectl get pods -o wide, I will see that these are the 3 IPs of the pod: 2.21, 1.19, 2.22, and here we have 1.19, 2.22, 2.21, exactly like this. This thing is clear. So we have now deployed this stack using imperative command. The backend stack is done. Now let's deploy the front end stack as well. I'll follow the same method. I'll write kubectl create deployment. I'll name this deployment front end deploy. Then I will write the image name. The image name I want to use is nginx. Then replicas I want R3. The port on which my nginx pods are listening is 80, so I'll write 80 here, and then I'll write dry run is equal to client -o YAML. I will redirect this to front end deploy.yaml. I now press enter, and now let me open the front end deployment from day 12. I'll open this here. I'll close the backend deploy, and here I will open the front-end deployment I just created. I'll bring this here. I'll close this. Here you have day 13's front-end deployment. Here you have day 12's front-end deployment. What we'll quickly do is we'll remove the fields that we don't need. We'll also remove the labels field, because these are the labels that are attached to the deployment itself, not the pods of the deployment. So we don't need these. We'll also remove this strategy. We'll remove the creation timestamp. We'll also remove these 2 lines from here. And then we know that we have this additional 2 lines. Ports container port is 80, and we also discussed that this is something that is just for documentation purpose, but it is a good practice to write this in your deployment YAMLs. I'll maintain the indentation. I'll maintain 2 indents, like you know. The key thing that I want you to notice here is when you are writing this imperative commands, you don't have an option to supply -- labels here, which is why I had to first redirect this into a file, and then we are editing this file. If this was not needed, then I could have directly run this command as well. Doing this served me 2 purposes. First, I have a ready-made YAML which I can edit and I can version control. Second is I can do the necessary adjustments. That is, I want to label this properly. I just want the label to be app is equal to front end, and from here as well I'll remove this deploy. Rest everything is same. The container name here is nginx, and here the container name was frontend -nginx. It is fine to have the container name as nginx as well, so we'll leave that as is. Now what I'll do is, everything looks good to me. Now I will go to the CLI and I will quickly apply this YAML. kubectl apply -f. I'll write frontend deploy.yaml. It says the deployment is created. Now that the deployment is created, I am ready to create the service as well. So what I'll do is I'll write kubectl expose deployment. Now the deployment that I want to expose is the front end deployment. I'll add a backslash, hit enter. I'll first flag that I want here is type. Type is equal to node port. I want this service to be of node port type. Then the port, the cluster IP port for this service will be port 80. The target port for this service, target port is the port on which my container listens, will be 80. Then I'll name this to front end svc, and then I'll add dry run is equal to client -o YAML, and I will redirect this to front end deploy.yaml. I'm adding double right angle brackets or double greater than signs to append the existing file and not to overwrite it altogether. Let me just quickly check. It's node port is 80, target port is 80. Yeah, name is frontend -svc. Okay, this looks good to me. I'll press enter now. What I'll do is I'll run kubectl get svc. I see that my backend service is created. Front end is not yet created because right now we just have the YAML for it. We have not created the front end service. I'll quickly add a YAML separator here, and I see I have this service already. We have the YAML with us. So you see, if I remove the unnecessary parts from here, then you see it is same as what we created here. I want you to know that, you remember we have 3 fields under spec: port, selector, and type. They need not to be in a sequence. The sequence is not important. So here port is 80, protocol is TCP. This was added by default, and then target port is also 80, and we have similar here. But the key thing here is this has not added the node port for us. If for example I would go here, and if I would have not written this, okay, let me show that to you. If I hadn't written this and pressed enter, then this would have created a front-end service for us, and it would have auto-assigned a node port. So if I run kubectl describe svc front end, then you would see that a node port is auto assigned. But in our scenario, we want the node port to be 31,000. So we cannot just press enter. Additionally, we want the YAML files, YAML output, because we want to version control this in production environments. Now let's go back to our terminal, and I'll quickly kubectl delete svc, and the name of this is front end because we'll create it from the YAML file itself. I'll go here now. I'll add an additional line here, that is node port, and the node port will be 31,000. I'll save this, and then I will go to my terminal and I'll run kubectl apply -f frontend deploy.yaml. I'll clear my screen. You see here, this says that the deployment is unchanged, which is expected, and it says that the service is created for you. I'll clear my screen. I'll quickly run kubectl get all. This will show me all the resources that I have created. This shows that there are 3 pods in front end, 3 pods in backend, which is expected. Then it says that there are 2 services created. One is of cluster IP, which is for the backend, and then there is a node port service, which is for the front end. And then the cluster IP assigned is also given here, and it shows that this cluster IP is listening on port 990, and this cluster IP is listening on port 80. And the node port is 31,000. Why we have specified 31,000? We have discussed this in day 9, that in day 12, sorry, that why we have specified a fixed port. If you have any confusion, go back to day 12 and watch that video. Now we have deployed all these 4 Kubernetes objects. Now it is time to test the connectivity. Now let's do one thing. Let's create a pod imperatively. Okay, let's go to the terminal. I'll clear my screen. Before I clear my screen, let's verify that our front-end deployment pods are indeed working fine with the service. I'll run kubectl describe svc frontend, I see the frontend service is distributing traffic to these three pods. And if I run kubectl get pods -o wide, ideally my frontend pods 1.21, 1.20 and 2.23, 1.20, 2.23 and 1.21. All these three pods are being load distributed using this service. I mean, the load is distributed to these three pods whenever request comes to this front-end service. Let's create a pod imperatively. Now we have done this before as well. kubectl run test pod. I'm running a test pod. I'll press enter. I'll write rm-it. -rm says whenever we'll exec into this pod, whatever we are creating, because I have written -it, it is saying that give me an integrated terminal. And -rm says whenever I press exit from the pod, just delete that pod. And we'll see how this works in a little while. Then I'll write restart is equal to never. This says if the pod fails, do not automatically restart it. Here is the new flag. This flag, I was not able to provide this flag for my deployments because deployments do not support adding labels to the pods imperatively. So when you create a single pod, you can supply labels. I'll have a label associated with this pod, app is equal to test pod. And then my test pod, the image that my test pod should use is nginx, and the command that I want to run is bin sh because shell is what I want to receive. If I press enter, I see that I am logged into the pod. Now how do I know? First is my command prompt has changed. Another is I can press control, hold on, I'll press command T to open a new tab. I'll just zoom in this. If I run kubectl get pods, I'll see that there is a test pod created. If I run this with flag show labels, then I will see that this pod has a label app is equal to test pod. And this is what we supplied here. Test pod should be the label, app is equal to test pod. And let's see whether we can reach our backend deployment. I'll write curl backend svc :9090 and I should ideally see hello from backend, and that is what I see, hello from backend. I want to show you a few more things. Let me quickly write curl. I'll write cat etc resolve.conf. Hold on, cat etc resolve.conf. You see that here it is saying the name server is 1096.0.10. What this means is if you want to resolve a DNS name, for example, right now this resolved backend -svc, this is saying your name server is 1096.0.10. But what is 1096.0.10? We have not deployed anything that has this IP address. Let's first quickly verify two things. As soon as I'll press exit, I'll write exit from here, then this pod will be auto deleted. I pressed exit and pressed enter, and this says the test pod is deleted. Why this is deleted? Because I supplied the -rm flag. If I would have not supplied this, then this pod would have stayed. If I go here and run get pods show labels, you see that test pod no more exists. We saw that 1096.0.110. Now let me do one thing. Let me write kubectl get svc. I'll add a new flag here. That flag is -n. -n allows me to specify a namespace. I'm saying get me services that are in kube system namespace. If I press enter, I see that there is a service called kubedns which is of cluster IP type, and that service is listening on port 96. That service's IP is this, and the name server for all the pods that we are creating in this lecture or we have created in past lectures, they all have the name server specified as this, and this is the cluster IP of a kubedns service. Now let's run a describe on this service and see what are the pods that are associated with this service. If I run kubectl describe -n kube system, I see that there are two endpoints which are listening on port 53, and 53, as we know, is the port number for DNS service. And then what I'll write here is I'll also show you kubectl get pods -o wide, and the namespace is kube system again. So the system related pods are often deployed in kube system namespace, and next lecture we'll be discussing Kubernetes namespaces and we'll get more clarity on Kubernetes namespaces. I'll press enter now, and you see that yeah, these are the IP addresses, and let me see, yeah, core DNS pods. There are two core DNS pods, 0.4 and 0.2, and if you see here 0.4 and 0.2, this is the reason whenever my front-end pods tries to communicate with backend SVC, the core DNS translates that name to the IP address of the cluster IP service that is associated with backend service. And now we know why the pod sends this to the specified core DNS, because the name server defined in each pod's etcresolve.conf is this IP address 1096.0.10. Now we can also go to our Chrome browser and verify that our front end is listening on port 31,000, and it is, which is why we are getting welcome to Nginx. So that's a wrap for this lesson. Today we learned how imperative commands can speed up Kubernetes workflows, from creating deployments and services to generating YAML files quickly. In our next lecture, we'll take a deep dive into Kubernetes namespaces, where we learn how to organize resources, manage environments, and enhance security within the cluster. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.